Okay, so we're going to look at one other example out of this section where we're looking at zeros that are either irrational or imaginary. So again, we'll begin with the rational zero theorem. We're going to identify the p, which is going to be negative 26, and the q, which is going to be 1. Remember, the p is the number that sits by itself, and the q is the coefficient in front of your highest power of x. Then we'll do factors of each one. So to make 26, I can multiply 1 times 26. I can multiply 2 times 13. And that's all. To make 1, just 1 times 1. So now we're going to make fractions, p over q. We're going to put each of our p values over the 1. And so our numbers really don't change. We still have 1, 2, 13, and 26. So this is my list of possible rational zeros. Remember that the theorem basically says that if our function has a rational zero, it will be one of these numbers in the list. So now I have to decide which of the numbers is actually a rational zero and which numbers are just extras. So we can look at a graph and make an educated guess about what the rational zero is. If you don't have a graph, then you're simply going to have to check some of these. So I might just start with 1. Remember that the check is to do synthetic division. So I'm going to have 1, negative 8, 25, and negative 26. And I'm going to drop that 1 down. 1 times 1 is 1. Add. 1 times negative 7. Add. 1 times 15. And add. So that's going to give me negative 11. So keep in mind that if you do not get a 0 as your remainder in your synthetic division, then that is not a 0 for your function. So I know that 1 does not work. Let me try 2. So I'm going to do the same thing with the 2. So I'll drop the 1 down. 1 times 2 is 2. And we add. 2 times negative 6, negative 12, and we add. 2 times 13 is 26, and we get 0. So I know now that x is equal to 2 is one of my 3 zeros. I know that I have 3 because that's the highest power of x. So I still need to find 2 other zeros. And so what I'm going to do, since I started with an x to the third, I know that I'm now down to an x squared. I'm going to put those x's back in. So I'm going to have 1x squared minus 6x plus 13 is equal to 0. So as soon as you get it to a quadratic, you can go ahead and put the x's back in and look at solving. Now, this is not something that I'm going to be able to factor. X squared minus 6x plus 13 does not factor into the 2 sets of parentheses. So, I mean, you can try it if you want, but it's not going to factor for you. So, my next best option, if something does not factor, is to use quadratic formula. So, I'm going to try that. So, I'm going to first write my quadratic formula down. And then I'm going to plug my numbers in. So my b value is negative 6. So I have a negative 6 plus or minus negative 6 squared minus 4 times a. My a is 1 times c. My c is 13. And then this is going to be over 2 times the a, so 2 times 1. All right, let's do a little simplifying. A negative negative 6 is going to be a positive 6. Underneath the radical, negative 6 squared is 36. 4 times 1 times 13 is 52. 2 times 1 is 2. 36 minus 52 under that radical would be 16, would be a negative 16. All right, and we can say that negative 16, we know the square root of 16 is 4, and because it's negative, we're going to have an I. So 6 plus or minus 4i over 2. And we can reduce this because all three parts are divisible by 2. So 2 goes into 2 once, 2 goes into 6 3 times, 2 goes into 4 twice. And so we end up with 3 plus or minus 2i. So those are my other two zeros for my function. So 3 plus 2i, 3 minus 2i. And if we were asked to factor this polynomial, then we know that we have a factor at x minus 2. That's going to correspond to the positive 2. Okay, and then oftentimes instead of having your factors become x minus something that's imaginary, we will basically go back to what we had before we either factored or quadratic formula, and we would use that as our other factor. So x squared minus 6x plus 13, and we would call that fully factored. All right, so that is our second example. As you can see, both of the examples work pretty much the same way, with the exception of how we're going to solve at the end. In one example, we simply were able to solve for x. In the other example, in this one, we needed to use quadratic formula.